I'm going to start machining the fixture plate that we're going to use to center up on the ID. This is a piece of steel that I had plasma cut out. It's 11 inches there and about. We're going to turn this down to 10.5 OD there, get this side faced, and then once we get this done, we'll flip it around, push it up against the jaws, and then machine the registered fit on the opposite side. Okay, we've already got everything touched. I've got some 0 points established. I'll go ahead and feed it in there. Pretty sure that tip of that carbide insert is going to have to be indexed. I think I chipped it whenever I first touched off. I was a little aggressive touching it off, and I think I chipped it when I did that. So let's just see what we got going on here. Yeah, it wore the tip just a little bit. And it only takes a little bit to make a big difference on the amount of tool pressure and the chip control. So let's see what it does. We'll swap that around. Take another cut here. I'm not going real heavy on this because I've got these jaws extended beyond what the safe distance is supposed to be on it. Yeah, I can tell that's a better looking chip already. Go into the 0 on that mag back indicator there. Get a little quick reference measurement on where we are. This is not a critical OD. I'm just shooting for 10.5. It looks like we're right around 10 inches, a little over 10-inch 9. Looks like 10.911. So I don't know, about 400 thousandths to come off of that OD there. Should have one cut left to take to get it down to our 10.5 here. Looks like 50, 60, 60, 61 thou. This kind of stuff here is perfect for these old vernier calipers. It makes reading this stuff easy. And I will point out that this is not the proper way to use the caliper if you're trying to take a precision measurement, but I don't need a precision measurement. But when I do it this way, you can usually get it really, really close, within a couple of thousandths, reading it that way. So yeah, I think I'm just going to dial in 60 thousandths, or maybe we'll slow the feed down and take it in 2 passes and try to improve that finish a little bit. Just try to put a little better finish on it, so we dropped it down to a 5 thou feed rate, and we took 30 thousandths on this cut here. Do one more thing. Run it a little bit faster. There we go. A little bit too slow on the surface speed. Kick that out. Now we got that pretty finish there. And we'll just take another 30 there. That'll be our OD. That looks good. Let's see what we landed on, just for fun's sake anyway. Yeah, 10.5, 501. That's what it's looking like. So now we'll go ahead and work on getting our face established. Just going to clean the face up. I'm going to use our DRO up here. Let's just move it in 10 and see if that cleans it up. Looks like that might get it. All right, I hit it with some Scotch-Brite. We got that cleaned up and also relieved the center just a little bit so there wasn't any kind of pip there that it might have been spinning on. So now we will go ahead and take this guy out. And I feel a little bit better about getting it down to the 2.5, getting it off of that OD that we're chucking on right now. First thing we'll do is just take it out so I can make sure those jaws are clean. Wipe the dust off of them. And we'll register right here on that face. I think we're ready for it now. That should be good. That should be good right there. All right. Now on this side, what we're going to have is like a registered step, so that whenever we put our I'm just going to grab our part here so you guys can see what we're talking about. This diameter right here, I want a registered step on there that we can set this down on so that it's centered up, and then we'll just clamp it on the inside. Just wanted to kind of get a touch off right there. See if there's two places that it's touching. I think right there and right there. Pretty close anyway. It's just a rough measurement. That's going to be, looks like about 11 inches, right around 50 thou. So I'm just going to go ahead and that was right there at it. X 11, and then what I'm going to do is let's bring that in to 8.5. That's our bore on our adapter plate is 8.5. So I'm going to make a witness mark right here. That's 8.5 right there. All right, so that should be a little bit over 8.5 right there. So that kind of gives me a really good witness mark. So I'm just going to hit 0 on that. So I'll take X to 0, and we'll go ahead and start facing this off. Use our Z up here. There's a 50 thousandths. Oh, you know what? I slowed the feed rate down. I need to fix that real quick. Should be right. I'm going to take a total of 3/16 down to this step right here, so I've got a little bit more to go, but I want to see if I can get this a little bit cleaned up. It's still in that plasma cut area, which tears up the tip of the insert. So I'm just going to see if I can, I'm just going to cut this by hand. I want to just clean it up round. There we go. Just feeding this by hand here. Getting what I can with that messed up insert. Go ahead and swap it out and get a better finish on everything. All right, so I just backfed it off that register that we're turning there. Now we'll start getting some closer measurements on this. That's the final face that I'm going to take right there. Let's see about what we got. So 8.5, and then we've got 40, right around 42 thousandths. So what we'll do is go ahead and change up our tactic here. Change our feed, longitudinal, 10, 20, and I need to slow this down. We want LCS 4W, there we go. I've already got me a 0 established on our depth there. Probably going to scratch that face. This has been some really stringy, gummy steel working with today. All right, so now we'll go ahead and use our vernier and see where we're at on our diameter here. Just get it to just touch, and we've got 8.5, 19 thousandths. So 8.519 is where we're at right there. I need to remeasure our part and make sure it's 8.5. All right, did some measuring. I think we've got 18 thousandths to come off of this, so I'm just going to go ahead and dial that in now. 5, 10, 15, 16, 17, and 18. We're going to cut this, and we're going to see if our part fits. These stupid chips, man. All right, let me grab the adapter plate and see if it actually go on there. That should give me 1 to 2 thou. Do not have a chamfered edge on there yet, so it's going to be a little hard to get it lined up. It feels like it's just right there together, same diameter. So we'll do some more measurements and see what we got here. It looks like 1 over, so 8.501. Let's just let's take another couple of thousandths. I'm going to go ahead and kick this back up to high gear. I'm going to take 2 thousandths. Now let's give it a shot and see. Super close. That edge on there is not helping me get it lined up either. It is just right there on it. It's so close. Maybe that'll help get it lined up. Let's break this corner too. See if that sucker will fit on there now. There it goes. Gave it about an extra 1 thou clearance there so it would try to slip on. It feels great. So that's what we were shooting for right there. And I'll make sure we're done, make sure all our edges are chamfered good. From here we'll go over to the mill, drill some holes. We're just going to power tap it and get it to where we can put some kind of clamp on here, strap clamps or something. Ideally what I'd like is another plate machined to be able to fit down inside here that had a hole with a stud, but that was one more piece to have to cut. So I think we're just going to use some of our strap clamps in this. We'll put some soft padding there so it doesn't mar it up. So yeah, from here we'll go over to the mill and get some holes drilled in there. Okay, we've got our steel fixture plate turned in the lathe there. So I'm going to go ahead and we're going to transfer punch a hole pattern in here to be able to hold it in the, to be able to hold our workpiece. All right, so this is going to allow us to hold our adapter plate for the final 2 ops that we're going to do, and I'll show you what we're talking about here. But just to make this simple, no programming needed, I'm going to just transfer punch some of these holes in here. We're going to go to the mill and drill it and tap it, and then we're going to drill 4 holes so that we can just bolt this down inside the mill. So I've got this turned to fit this bore, like so. And then my plan is to use some 832 bolts to hold this down, utilizing these 3/16 holes in here. So we're just going to put a couple of these clamps on here to just kind of hold this in place. All right, and we're going to go, let me see, it was, I think we're going to do 8 holes. 1, 2, 3, 4, and we'll go 5, 6, 7, 8, something like that. We're going to use, we got a transfer punch set right here. We want the 3/16. These transfer punches, you only want to hit them one time. If you hit them too hard, they will snap those tips off because these are just a little cheapsy punches. All right, so that's 4. It's not going to be a completely even pattern, but I definitely want 4 on there. So I think we'll go these. That's all it takes. That would be something nice to make an index for. Get rid of that little cheap stamped metal case. All right, I can see our punch marks. Looks good. 1, 2, 3, 4, 5, 6, 7, and 8. All right, so we'll head over to the manual mill, get these holes drilled, and then I'm going to just use the flex arm to tap these guys. I do want to punch these one more time. We're just going to use one of our Starrett prick punches here. They're nice and sharp. It'll open that center point up just a little bit more and make it a little easier to line up on. that'll work. So we'll put the center point. This is just a ground center point there. You can put in your drill chuck or collet, and we'll just line up the punch mark, clamp it down, drill the hole. All right, we're going to try to keep this as simple as possible here. We've got our center point. There we go. Once we line up on our center point there, I've just got this one right height clamp that we can use to hold it in place. Not a lot of pressure on this little drill we're going to be using. All right, we're going to go with a number 29 jobber drill. That's tap size for 832. I'll tell you what, so the depth is what will change a little from here. I'm going to just bring it down like this. I'm looking up at the scale on the quill. I'm just going to line it up with an even number there. That's the 1 inch mark. And then we'll just tighten it up right there. And then I'm just going to take these holes a 1/2 inch deep, and then we'll power tap them with the flex arm. The other thing I want to do is I'm going to use my mist here. This is going to be our trim mist. It's 1200 RPM. Let's give that a try. Take it down a 1/2 inch deep. Perfect. Loosen our clamp. We got to take our drill back out. Put our center back in. I'll even chamfer them using the flex arm too, because that'll just make that job even easier. This is the trickiest part, just eyeballing the center point. And then once it finds it, it'll pull it to the center. Tighten your clamp. That lined up on 1 inch right there. Just as easy as that. We'll keep working our way around. Do that 6 more times. Well, that takes care of the tap size holes for our 832 bolts. I'm going to go ahead and put this guy on some parallels to pick it up off the table. And then we'll go ahead and center it up and then we're just going to drill 4 holes here for 1/2-inch bolts to be able to bolt this down to the fixture. This is where it would have been helpful to have a center drilled in the middle of that, and we could have just used our center point to easily find the center. But we didn't, and I don't feel like setting it up in the lathe just for that, so we'll put a test indicator in here and indicate this register fit that we machined on it. I got these brass shims I was going to use as well. Try to keep from marring up that flat surface we're going to clamp down on. Give ourselves a little bit of room for the indicator to get in there. We can at least use our pointer to kind of line us up near the center. We can do that. Oh, come on. Got to unlock that table. It's pretty close right there. All right, we've got this edge indicator arm set up and a stair test indicator. This is the 811. All right, this side's low. This side's low. Pretty close. We're within about a thou right there. That's within a thousandths being in the center. I like having the 811 for jobs like this. This is why I've got this one, is so that you can pivot this dial face up and you can just stand right here over it and you can see all the positions without having to come around here or hold a mat or a mirror or something like that. Just very convenient indicator. So I'm happy with that. We're going to go 0, 0 on our DRO, and then we'll just step it over 2.5 inches each direction to put it on 1.25 inches center to center for the whole pattern and the fixture plate on the mill. Okay, we're ready to spot our holes. I've got a 1/2 inch spot drill in there, and we're going to offset our movements 2.5 inches each direction. All right, so we'll just start this way. All right, 2.5. Just doing some quick visual verification. Yeah, 2.5. And if we line it up with the 1 mark there, so that'll put us on a 5-inch center to center. Okay, that looks good. This is just a spot. All right, That'll work right there. Brought our Y back to 0. All right, and then I'll grab a drill and we'll go ahead and get our holes drilled in there. All right, for our jobber, we're going to go with a 33/64. This is a Chicago Latrobe. Got to drop the knee down some. Line up on our flats. See if we can get our mister down there by it. Looks like we can. Okay. Go to the other reverse. All right, that's about 250 RPM. We'll give that a shot. All right, that worked great. Move it down to our other hole. While we're set up here, I'm going to go ahead and drill and ream a 1/2 inch hole in the very center on our XY0. That way, whenever we go to the CNC mill, I can just indicate this center hole instead of sweeping that whole thing, make it a little bit easier. Or should I say probe, just probe the center of it. So I'll get my cutting tools ready and I'll go ahead and get that hole completed too. And for that, why not just go with the A-Bomb 79 drill index there. We're going to go with the 31/64 right there. Okay, now I have a 1/2 inch reamer installed, so we'll go ahead and get it reamed, and then after that we'll put a chamfer tool and chamfer all those holes. All right, chamfer tool installed, and what I'm going to do is just run it down against the hole here and then bring our stop up there. And I've got the handle on the knee, so all I got to do is just feed it up a little bit to kind of get it to the same depth. That way we can just chamfer all those the same depth there. All right, that looks pretty good. Go up a little bit further since that's a bigger hole there. Give it about a 10/1000 chamfer. I think we're all finished up in the mill. Go ahead and break the setup down. I'm going to go over to the flex arm table and we'll chamfer the bottom side over there and chamfer all these holes and then tap them. Get it hooked into our Kaiser air supply here. All right. Yep, that'll work right there. I think we'll just use the bolt. Yeah, that's gonna reach out here good. Let's just use a bolt. We'll hold that down with that. All right, first thing we'll do is just go ahead and get our small holes chamfered. Yeah, use that little guy there. That's definitely working pretty good right there. I had a little bit too much force on it. Just a quick hit, that's all it needs. Yep, it's working good. Here's the tap that we're going to run today. This is a Cleveland 832 spiral pointed tap. Here's our holder. I'm going to use my dark cutting oil today. I keep it in my little Eagle number 33 oiler right here. And since we don't have a lot, we're just going to fill them holes up like that. Let's see how it does. I'm always nervous because last couple times I did some rigid tapping in the machine, the taps broke, so I just get really nervous. But if you trust this stuff, it will work. Seemed like it did a good job. Let's try it again. It's working good. Just want to go ahead and check one of the bolts. Perfect. Okay, well, we had a successful power tapping operation for all 8 of our holes there. I was a little bit gun shy just because of, you know, previous broken taps there in the machines with the rigid tapping, not over here. But just these little tiny taps just make me super nervous that maybe the clutch is not going to give way and it's going to snap a tap off in there. But they are designed to slip. So all of these holders here for the flex arm, they have a little clutch in there. So once they reach a certain torque, they're supposed to spin, preventing any kind of tap breakage. So they do work, and it's very convenient to do stuff like this, and less stressful than rigid tapping in the machine. So I think this guy, our machining of our fixture plate here, I believe is done now. From here, it's moving over to the Miltronics and getting it set up and mounted into the machine. I would like to give this a test, make sure it bolts on correctly. Looks like they're all lining up. Length of my bolt looks good too. I got 5/8 long 832 bolts. That gives it a 1/4 inch thread engagement down inside the hole. That is going to work nicely right there. All right, so next step of this, really all we're doing with this fixture is holding this part so that we can machine the outside off of it. So once we get this fixture plate set up and this bolted down to it, will be in the center there. What we're going to be doing is machining all 4 corners off and bringing it down to the finished diameter on this OD. And then we're going to machine a radius on this outside corner there. And then once we get through with that, all this material will be moved out of the way. I can take this off, I can flip it upside down, and I'll be able to machine the radius that's on the bottom side right now. We'll flip that over and I'll be able to reprobe it, and we'll be able to just machine that radius using a ball mill. So that's the plan. So from here, I'm going to break this down. I'm going to move over to the Miltronics and start getting it set up there.